Hello everybody, welcome into another lesson. So today we are going to talk about the square root of variable expressions. So here we see the square root of 121a squared. Well, kind of like from yesterday's lesson, you have two factors being multiplied. You have the 121 and then you have the a squared. So we can start by separating those into their own square roots. You could separate it into the square root of 121 times the square root of a squared. Well, we know for sure the square root of 121 is 11, right? So, there's that part. Now we have the square root of a squared. Well, some would think it's just simply a. However, when you have the square root of just a number to the of a variable to the second power, it's actually going to be the absolute value of that variable to the first power. So the real answer you're going to get is 11 times the absolute value of a. Well, why is it the absolute value of a? Because the reason is we don't see a negative sign in front of the square root, right? And it's impossible, at least in the real number system, for the purposes of this course, Algebra 1, we're only working with the real number system. It's impossible to take the square root of a negative number. It just doesn't work. There's no number that you raise to the second power that would give you a negative number. It just doesn't work. So you have to make sure you'd have the absolute value of a. That way, no matter which value of a you pick, the result's always positive. That's why. Because we know the absolute value of any number is always a positive number, right? So that's why it's going to be 11 times the square root of a, 11 times the absolute value of a for your solution. All right. What do we got here? We have the square root of 100 z to the second. So we got the square root of 100z to the second power. Well, we can start by separating the 100 and the z squared, so we'll have the square root of 100 times the square root of z squared. Well, we know the square root of 100 is definitely 10. You'll get 10 for that part. But the square root of z squared, that's going to be another absolute value of z. So the real answer you're going to get is 10 times the absolute value of z. All right. Now we have here the square root of 28x squared. So this time we have the square root of 28x squared. Well, we can separate this into the square root of 28 times the square root of x squared. But immediately we notice we have the square root of 28, which is not a perfect number. That means it's not a perfect square. But we can separate it into factors where at least one of them is a perfect square. Square root of 28, you'll have the square root of 4 times the square root of 7. Then all that times the square root of x squared. So then what you're going to get here, well, we know the square root of 4 is 2. Square root of 7, there's nothing we can do with that. It's not a perfect square, but the square root of x squared, that's going to be the absolute value of x. So you'll have 2 times the absolute value of x times the square root of 7. That would be your answer for this one. You would get 2 times the absolute value of x times the square root of 7. Okay, how about the next one? Alright. Square root of 32b to the fourth. Well, we have the square root of 32b to the fourth, so it's not b to the second, it's b to the fourth. Well, we can separate these into the square root of 32 times the square root of b to the fourth. Okay? Well, 32 is not a perfect square, but we can separate it into factors that are a perfect square, such as 16 and 2. So you could take the square root of 16 times the square root of 2. So there's for your factors of 32 times, let's deal with this b to the fourth. Isn't it true that b to the fourth is simply b to the second power? Wouldn't that be true? B to the second power is b to the fourth. So we can separate it like that. Now, we know the square root of 16, that's 4. There's nothing we can do with the square root of 2. That's not a perfect square. But the square root of b to the second, that's just going to be b to the second. And since the answer is to the second power, we don't need an absolute value sign. The reason being is because no matter what value you put in for b, it's going to be positive. So we can leave that as 4b to the second times the square root of 2. That would be your answer. So you would end up getting 4b to the second times the square root of 2. All right. Now let's do this. Negative of the square root of 9c to the fourth. So we have the negative of the square root of 9c to the fourth. Well, we can separate this into negative of the square root of 9 times the square root of c to the fourth, because your answer is ultimately going to be negative because you have a negative sign outside of the square root. So only one of the square root factors needs the negative sign in order to keep this whole thing negative. Well, good news is negative of the square root of 9, that's negative 3. So that part checks out. But we still have this square root of c to the fourth. Well, isn't it true that c to the fourth, isn't that just c to the second power? So now we have negative 3 times the square root of c to the second raised to the second power, which that's simply going to end up being negative 3 c to the second power. That's what you would end up getting in the end, is negative 3 c to the second power, because the square root of c to the second, that's c to the second, and we don't need that absolute value sign because c to the second is always positive, and a positive times a negative gives you a negative. So that would be your answer for this particular one, would be negative 3c squared. All right. How about negative of the square root of 64x squared? So we have negative the square root of 64x squared. Well, only one of these square roots that we split it into is going to need the negative sign. So we'll just do negative of the square root of 64 times the square root of x squared. Right? Well, negative of the square root of 64, that's negative 8. And then the square root of x squared, that's the absolute value of x. So the answer you should get is negative 8 times the absolute value of x. All right. We have negative of the square root of 25 d to the sixth. So we have negative of the square root of 25 d to the sixth. Well, once again, only one of these factors is of the square roots we split it into is going to need the negative sign. I'm going to put it on the square root of 25. So you'll have negative of the square root of 25 times the square root of d to the 6th. Well, negative of the square root of 25, that's going to be negative 5. You'll have that times, let's take care of this d to the 6th business. Isn't it true that d to the 6th is the same as d to the 3rd raised to the 2nd power? If you think about it, d to the 3rd to the 2nd power, that's going to be d to the 6th. Well, what you're going to have here then is you're going to end up having, what you'll end up doing is having negative 5 times d to the 3rd. That's what you would end up getting, is negative 5 d to the 3rd. But again, you're always going to want to keep, in this case, your result negative. So what you're going to have to do here is you're going to have to split this further into negative 5 d to the 2nd times d, which really, what it's going to end up being is negative 5 d to the 2nd times the absolute value of d. The reason for that is we want to ensure that no matter what value of d that we put in, the answer is always negative. That's why it's going to be negative 5d squared times the absolute value of d. All right, we have negative of the square root of 16 d to the 8th. Okay. We have negative of the square root of 16d to the 8th. Well, this will split into negative of the square root of 16 times the square root of d to the 8th. Well, negative of the square root of 16, that's negative 4 times, all right, isn't it true that d to the 8th is simply d to the 4th raised to the 2nd power? Wouldn't that be d to the 8th? So now we take the square root of that, you'll get negative 4 d to the 4th. And we don't need an absolute value sign on the d to the 4th, simply for the fact that no matter what value of d you put in, your answer is going to be negative. So the square root of this would be negative 4d to the 4th. All right. We have the square root of 80a squared b squared. So now there's 3 parts to this. We have the square root of 80a squared b squared. Well, we could separate this into 3 parts. We would have the square root of 80 times the square root of a squared times the square root of b squared. Well, we know 80 is not a perfect square, but we can split it into 2 factors where at least one of them are. Well, that would be 16 and 5. So we could take the square root of 16 times the square root of 5 times the square root of a squared times the square root of b squared. Okay. Well, square root of 16, that's 4. Square root of 5, there's nothing we can do with that. That's not a perfect square. Square root of a squared, that's the absolute value of a. Then the square root of b squared, that's the absolute value of b. And then you just have the square root of 5. Which, when you have two numbers that are products of each other in absolute values, you can combine them into one absolute value. So you'll get 4 times the absolute value of AB times the square root of 5. That would end up being your answer. 4 times the absolute value of AB times the square root of 5. Okay. Square root of 49 a squared b squared. So it's similar to the last problem, only this time we have square root of 49 a squared b squared. Well, this can, again, we'll split into 3 parts. We'll have the square root of 49 times the square root of a squared times the square root of b squared. Well, square root of 49, that's 7. Square root of a squared, that's the absolute value of a. Square root of b squared, that's the absolute value of b. Which again, when you have a product of two variables that are absolute values, you can combine those into one absolute value. You'll end up getting 7 times the absolute value of AB. And that would be your answer. You'll get 7 times the absolute value of AB. Oh, good one. Square root of 75 r to the third. So we got the square root of 75 r to the third. Well, this is a good one. We'll still split this into 2 parts. We'll take the square root of 75 times the square root of r to the third. Alright, well, the square root of 75 is not a perfect square, but we have at least one factor of it that is. That's going to be the square root of 25 times the square root of 3. And then we got to deal with that square root of r squared. Of r to the third. R to the third is the same as r to the second times r, right? Which is going to leave you with the square root of 25 times the square root of 3 times the square root of r squared times the square root of r. Okay. Well, let's start here. Square root of 25, that's definitely 5. Square root of 3 we can do nothing with. That's not a perfect square. Square root of r squared, that's going to end up being r. It's not the absolute value of r. I'm going to tell you why not in just a minute. And then square root of 3 we can do nothing with. And then you have the square root of r, which we know when we have 2 square roots to multiply by each other, we can combine them into one square root. You would end up getting 5r times the square root of 3r. So you may be wondering, why is there no absolute value on this r? The reason is because underneath the square root there's an r also, and it's understood that for the square root function that you can only have numbers 0 or greater for your values. If r were to be a negative number at all, it would make the whole thing undefined. So, therefore, we don't need an absolute value on the r. We know all numbers are going to be positive then, because we're going to make this whole thing defined. So your answer is going to be 5r times the square root of 3r. Alright, we have the square root of 80 n to the sixth. So we got the square root of 80 n to the sixth. Well, once again, we can separate this into two different square roots. We can do the square root of 80 times the square root of n to the sixth. Well, 80 is not a perfect square, but we got two factors where one of them is. That would be the square root of 16 times the square root of 5 times, okay. Now, isn't it true that n to the sixth is simply n to the third raised to the second power? That would give you n to the sixth. Well, what we have to do now is you're going to end up getting square root of 16, that's 4. Square root of 5, there's nothing we can do with that. That's not a perfect square. But you'll have the square root of n to the third squared. Well, that would be n to the third times the square root of 5. But there is another thing here. We want our answer to always be positive. So we got to do 4. N to the third is n to the second times n times the square root of 5. Well, what we want the answer to always be positive. So in actuality, it needs to be 4n squared times the absolute value of n times the square root of 5. So the answer you're going to get for this hot mess is 4n to the second times the absolute value of n times the square root of 5. This ensures that sticking to the original, which was positive, you'll always get a positive answer no matter what you put in. So 4n squared times the absolute value of n times the square root of 5. Okay. We have negative of the square root of 144 x squared z squared. So we have negative of the square root of 144 x squared z squared. Well, we could separate this into three different square roots. We'll take negative of the square root of 144 times the square root of x squared times the square root of z squared. That would be our next step. Well, negative of the square root of 144, that's negative 12. Square root of x squared, that's going to be the absolute value of x, times the square root of z squared, that'd be the absolute value of z. And the reason these are still absolute values are because we want to ensure we always get a negative answer, since there's a negative sign on the original. That way it would ensure no matter what values of x and z you put in, you get that negative answer, which we know negative 12 times the absolute value of x times the absolute value of z can be simplified as negative 12 times the absolute value of xz. And that would be your answer. You'll get negative 12 times the absolute value of xz. Alright, what do we have here? Negative of the square root of 400 a to the sixth, b to the fourth. So we have negative of the square root of 400 a to the sixth, b to the fourth. So we'll split this into three separate square roots again. Let's do negative of the square root of 400 times the square root of a to the sixth times the square root of b to the fourth. Well, let's start this here. Negative of the square root of 400, that's going to be negative 20. And then you have, all right, the square root of a to the 6th. So isn't it true that a to the 6th, isn't that simply a to the 3rd raised to the 2nd power? That'd be a to the 3rd to the 2nd power. So basically, you could think of it as when you have a square root of something to a power, if it's an even power, you just divide the power by 2. But be very careful because you may have some absolute value signs. So it's not quite that simple, but it's almost that simple. All right, times the square b to the 4th. Well, that's simply b to the 2nd power. So what you have here now is negative 20 times the square root of a to the 3rd raised to the 2nd, that's a to the 3rd, times the square root of b squared to the 2nd power, that's going to be b to the 2nd. Well, we want the answer to always be negative, don't we? What happens though if right now if I stick in a negative value for a? A negative number raised to the 3rd power is also negative. You would therefore end up having a negative times a negative, which would make it positive, because no matter what number you stick in for b, it's to the 2nd power, it'll always be positive. So we're going to have to separate this a to the 3rd a little bit further. That's the reason why. So you'll have negative 20. All right, a to the 3rd is the same as a to the 2nd times a times b to the 2nd. Well, what we have to do now with that a by itself, we need to place an absolute value sign on it. So you'll end up getting negative 20 a squared b squared times the absolute value of a. Now this ensures that no matter what number I put in for a, my answer is always going to be negative. So now with the absolute value in place, I can always put it, I could even put in a negative number for a and I'll still get a negative number as my answer. So that's why it works that way. So negative 20 a to the 2nd, b to the 2nd times the absolute value of a. Let's see. Here's an interesting one. Square root of x to the 4th, y to the 6th over 4r squared. So now all of a sudden we have division going on in the square root. So we have the square root of x to the 4th, y to the 6th over 4r squared. Well, this does separate, okay? Just like with multiplication, you can separate your square roots in division also. Let's focus on the numerator first. If you have the square root of x to the 4th, y to the 6th, that will simply separate into the square root of x to the 4th times the square root of y to the 6th over your denominator. Now, you have square root of 4r squared. Well, that'll separate into the square root of 4 times the square root of r squared. So that's how we can separate that problem, okay? Now let's go ahead, let's take the first one here. Let's start breaking this down. Square root of x to the 4th, well, that's the same as the square root of x to the 2nd raised to the 2nd power. Times, now y to the 6th, that's the same as y to the 3rd raised to the 2nd power. You would have that all over your square root of 4 is 2. Then your square root of r squared, that's the absolute value of r. So in the denominator, we're already done. We have in the denominator 2 times the absolute value of r. And then let's take this a step further. Square root of x squared to the second, that's just x squared. We don't need an absolute value for x to the second because no matter what value I put in for x, it's always going to be positive. However, that square root of y to the third to the second, it's going to be different. So you'll end up temporarily getting x to the second y to the third over 2 times the absolute value of r. But we're not done yet. The original expression's positive, right? Which means we should get a positive result for our answer too. But the problem is if I stick in a negative value for y, anything negative to the third power is negative. That's going to make this whole thing negative. So this is why we're going to have to separate like we are. You end up having x squared. Y to the third is the same as y to the second times y. Then we'll have that over 2 times the absolute value of r. But we need an absolute value sign on the y to the first in order to make sure the whole thing stays positive. So your answer you should get is x squared y squared times the absolute value of y all over 2 times the absolute value of r. That would end up being your answer. In order to make the whole thing positive, now no matter what value I put in for y, the whole result's going to be positive. So it's going to be x squared y squared times the absolute value of y over 2 times the absolute value of r. All right, let's see here. This is another good one. We have the square root of 45 m to the third n to the second all over 5 m n to the fourth. So we have the square root of 45 m to the third n to the second all over 5 m n to the fourth. This is all inside the square root. Well, good news is you can basically treat square roots when you have a problem like this as parentheses almost. So you'll treat this whole expression inside the square root as if it were in parentheses. In other words, you can simplify this. So this will be equal to the square root of, all right, 45 divided by 5, that's going to give you 9 in the numerator. So then you'll have m to the third over m, that's going to be m to the second, all over, now you have n to the second over n to the fourth. This will end up being over n to the second. So what your expression simplifies to is the square root of 9m squared over the square root of n to the second. So this isn't so bad now since we simplified it. Yes, we could have picked this apart piece by piece. We could have done that, but that wasn't necessary if you can simplify everything in there before you start. Now, we can separate these square roots. In the numerator, we have the square root of 9 times the square root of m squared over the denominator, which is going to be the square root of n squared. Which this will be an open and shut one. Square root of 9, that's 3. Square root of m squared, well, that's going to be absolute value of m over the square root of n squared. That'll be the absolute value of n. So the answer you really should get here is 3 times the absolute value of m over the absolute value of n. And again, since your original expression was positive, the absolute values ensure that the answer will stay positive. That's why we do the absolute values when you have odd powers. Notice if you have odd powers, and we'll explore this more in Algebra 2 when we get into higher order algebraic equations, any number raised to an even power will always be positive, whether it's positive or negative. Any number, if it's a negative number raised to an odd power, it'll always be negative. So there's a sneak peek at Algebra 2 for you a little bit. Alright, I got two more. Here's a funny one. We have the square root of y squared minus 8y plus 16. So we have the square root of y squared minus 8y plus 16. Well, let's start with what's inside the square root first, okay? It would probably be safe to say this is a perfect square trinomial, right? Or perfect square binomial, a perfect square trinomial. So this will factor into the square root of y minus 4 to the second power. Because if you take this to the second power, you will in fact get y squared minus 8y plus 16, okay? Well, you would think the square root of y minus 4 squared is just y minus 4. Well, that's partially true. Partially. But it's not entirely true. Because your original sign on the original square root is positive. You want a positive answer, do you not? So you could put in some value for y and get a negative answer, which you don't want. So the answer you should get would be the absolute value of y minus 4. That way it ensures you get a positive answer no matter what. You'll have the absolute value of y minus 4. And I got one more problem and then we are done. It's a similar type of problem. So let's see, we have the square root of m squared minus 12m plus 36. So we have the square root of m squared minus 12m plus 36. I would say it looks like we can definitely factor this, can't we? And we certainly can. That'll be the square root of m minus 6 raised to the second power. And if you expand this back out, you would get m squared minus 12m plus 36. So now you'll take the square root of m minus 6 raised to the second power. You'll end up getting the absolute value of m minus 6. The reason being, again, for the absolute value sign, if you're wondering, is because the original expression was positive. You want your answer to be positive, and the absolute value ensures that you'll get a positive answer. So you'll get the absolute value of m minus 6. So that's it for square roots of variable expressions. Next lesson, we're going to dive into something that's kind of familiar to most of you, or if not all of you by now, the Pythagorean theorem. That's one of my favorite topics, the Pythagorean theorem. So I hope everyone has a good night. Take care.